So here's where we are. We have our building. We'd like to take one of these buildings and actually make it into something that really looks more like a building. Okay, so let me go shifting over and see if we can find one I like. Like that one. Maybe we'll make that one into a building. Okay, I've decided that this is my favorite for no particularly good reason. I'm going to actually turn off this mode to say show the form again. Okay, and we're going to start converting this building. And this workflow we're going to look at is actually called the Buildingmaker workflow, but it actually works pretty straightforward. Let me kind of give you an idea of what it's like. In the Massing and Site tab, there are actually several tools that let you do something called modeling by face. And what they do is they let you take the face of something that exists in the conceptual model and really use it to place the mass, or a real building element, excuse me. So let me show you how it works. For example, I can choose the floor tool, choose a type of floor. For example, I'll just leave it at generic for right now. I'm going to choose that floor, that floor. Okay, and when I say create a floor, what it's actually going to do is take those mass floors and actually turn them from mass floors into real Reddit floors. Okay, so we can use this ability to kind of take the math and generate things very, very quickly. Very quickly. Let me see what's going on with my headset. Can you hear me?
Yeah, we hear you.
Okay, I think we're good. Oh, no worries. My little headset's talking to me, saying strange things. Okay, so I can create forms out of like floors. And these floors are every bit as good as the floors that you create by just editing the boundaries. In fact, you can even edit the boundary if you want and make some customization to it. So, for example, if I want to change that floor, oh, maybe that's not such a good example. Maybe this one down here. On the second floor, maybe I want to edit that one. And, I'm going to create some sort of, what would I say? I'm going to round something out a little bit just so I can, I want to do that. That's interesting. Can I not draw there? Won't let me do it in 3D. That's interesting. Da, da, da. Trim that up. Interesting. It's not going to let me figure out why that is in a second. Okay. So what I have now is I just sort of cut like a little bit of atrium out of that space. Just by cutting back that floor in that area. So you can go through and edit these things just fine. That works just fine. As long as the surface you're placing tends to be relatively rectilinear, relatively horizontal or vertical, everything works just fine. So for example, let me put some walls on this building. I'll take the wall tool and I'll choose one of the wall types. For example, let's go ahead and put this exterior EIFS system. We still have the issue of when we place this, which face it's going to be on. So I'm going to change it to core face exterior. That's the notion of really what surface of the wall will be right where the boundary of that mass is. Is that boundary of the mass the outer side of the skin, or is it the side of the structure? I can put a wall right there. And I'll put a wall on this side. And again, these walls are every bit as good as the walls that you created other ways. So for example, if I want to go through and put some windows in, I want to put some doors in, whatever it is, and I'll apologize again, it's going to be an ugly building. Okay, but I can go through and use this form to just really generate those things. Okay, a couple other types of elements that are good to put on here are, I can put a roof on this. Oops, I have to do it by massing in sight. Hang on. Cancel. Roof right there. I'll choose some sort of roof I want in there, like a steel truss with insulated metal decks. I can choose this. Now let's stop and just pause for a second and think about this roof. This roof is a little bit different than those wall surfaces. Because can you see that the roof actually is sloping up a little bit? Okay, and if we do have the roof sloping up a little bit and create it, it'll create a roof there, but I can't actually edit the footprint the way I would normally edit the footprint. And here's the difference in terms of working with different things or different types of ways of putting form on here. Oh, for example, if I put a roof on this building back here, okay, where it's perfectly flat, okay, I could go ahead and create a roof. Put it on there. This roof over here, well, I'm taking that back. It's not going to let me change it. It's interesting. Walls are a little bit different. It's not going to let me go through and just edit its footprint because it really wasn't defined as a footprint. So what I might want to do on that roof instead is I can still use my form, but I can make a footprint roof. I'll put it up on like level 3 or 4 or whatever it was. And I can pick the walls. Looks like it's level 3. I can pick the walls. So I'm still using my form, but I'm using it in a different way. Here I'm just using it as a way to help me trace those surfaces. So here I am. I'm going to turn off that defined slope. Okay. This roof looks amazingly like the one I put by just placing the surface, but it has the ability to edit the footprint. So I can go through and do things like defining a slope, make changes to it. So just watch out for that distinction. When you create the masses, you can use them to actually just sort of put something all over the surface, but sometimes you lose control by doing that. But you can also go through and just use the mass as a tracing template, just to start tracing a boundary so you don't have to recreate all that from scratch. So a number of different ways we might get into in terms of doing that. Actually, if this were Y2E2, let me just edit it, or the SEQ quad, it really looks more like, just so you get a sense of it. Okay, but all our roofs over here do this. Actually float above the building. Oh, that's a little far. Oh, 0'6", that's not good. 6'0". Okay. That's more like what the roof on Y2E2 looks like. Yeah, some variation to it. Okay, let's go ahead and talk about these front and back walls a little bit too. Now for these front and back walls, I had the idea of actually making a nice curtain system. I'm going to choose curtain system by face. I'm going to create a bigger grid. I don't like 5 by 10. This is only 5 feet tall by 10 feet wide. So I'm going to duplicate this and make something that's 10 by 10. Hopefully you're seeing that everything we learned so far kind of plays right into this. All the same sort of ideas about how we create objects and elements are still applying here. We just have a different technique for placing them. So I can choose that. Say create the system. Got a nice curtain wall right there. Maybe I'll put a curtain wall on the back side too. So I'll grab this wall. I'll say place the system. So I actually have, it's hard to believe, but I actually have a pretty reasonable building there. And what I want you to sort of take away from this is that the conceptual massing and then applying these surfaces to the skins was a whole lot quicker than trying to draw this all from scratch and build it up piece at a time to kind of make this little 4-story or 5-story building. You know, pretty good if we're getting started. You know, you may go ahead and decide later on that your conceptual math just isn't quite right. You want to go through and make some changes to it. Let me just show you how that works, because that's possible too. The mass is here. You just can't see it. It's kind of buried alive under all these building elements. If I tab a few times, I can get it. I can tell down in the status bar, down in the lower left-hand corner, I can see it's a mass, low flat building. I'll choose it. And I can edit that. Let's talk about what you can do. So, if I decide that I really want the building to be a little bit longer on the site, I can stretch the math out. Maybe I decide that this overhang needs to be even more severe. And I'll change that. I'll finish my math. I'm just making a few changes to the math. We'll let that be for now. Okay, now that's okay, but you might notice there's a little bit of a disconnect between my building and my math aren't together right now. They're kind of two separate things. Okay, so if you would like your building to reshape itself so it readapts to the math, okay, you made a change to the math, you want to incorporate that change, have all the work that you put into detailing the building, inherit those changes. Here's what you do. You choose the surface of the building, and you can say, update it to the face. And what does that do? That says, for this surface, you were generated by a math space, you've made a change to the math space, and now you want to update it so that it follows the math space. So it pulls it up. We can do the same thing over here to that curtain wall, pull it down. What you may want to do, just because I would really like the whole building to adapt, you just orbit it down, whatever it is. I could have done this the other way. And I'm just going to highlight the entire building. Maybe I can't do that. That would have been so nice. Let me see if I can just get... Well, I don't want to do the doors and floors. That's actually... Well, the doors I don't want. Floors I want. Math I don't want. Math floor I don't want. Roofs I want. And windows. I'm just choosing the things that I want to have adapted. See if that'll work. Let me take the curtain system out. I'm trying to think about why I want one to do it. Oh, let's modify there. Once again, it's not doing what I like. Okay, well, do it manually. Update it to face. If I get all those floors. You'll find I'm very hard-headed and don't like to give up on things when software's fighting me. I can update all those. Let me grab this last final thing and update that. Okay, so hopefully that wasn't too bad. So, got that wall over there still. Okay, one more wall. Update it. Okay, so let's just pause there for a second about this whole notion of this Buildingmaker workflow and see how that feels to you. Can you sort of see how we can take a conceptual mass and just add these surfaces? Use that as the beginning of dictating the skin of a building?
Yeah. Oh, okay.
Yeah. Okay.
Professor, would you say should we develop the habit of doing it this way instead of what we did the first 2 weeks, or just depends?
Go ahead. I didn't quite hear that because you're a little far from the microphone. So, Lottie, can you repeat the question?
Yes, he said, should we develop the habit of building this way or the previous way we've been doing with architecture tab? And
it depends on whether you're going top down or bottom up. If I'm really doing several 100,000 square feet of a big building where we're really going to determine the ultimate form first, and then sort of subdivide it and optimize the space within that form, go this way, and you'll find that most commercial buildings of any scale tend to be done this way. So I'm putting a big tower in the middle of Shanghai, I'll do it this way. I'm doing new housing blocks in the Middle East, I'll do it this way. You know, there's some question of scale when buildings get, over 10,000 square feet, 20,000 square feet. Just the way designers think about them just tends to be different. So it's really, it comes down to really, is your designer thinking bottom up? Or are they thinking top down? Maybe they meet somewhere in the middle. Yeah, because it's, I don't know. Yeah. Good question. It really is sort of an overall question of strategy. So hopefully, I think you're going to see that either way takes you to very simple places. Although, let me give you a kind of a variation on that answer that may make a difference. You know, as we were drawing those sidewalls and putting windows in them and floors, we could have done that the other way. That would have worked. The difference in this technique is you see that big sloping piece of glass on the front? Okay. You know, we couldn't have created that the other way. The only way I can create a wall that slopes, that's non-vertical, is to do something like this.
okay.
Or let me even kind of take it one step further, because for the architects that are in the class, I don't think we have many there tonight, do we? If I, for example, pull that out and pull this up and finish it, okay, we've again created sort of a very funny geometry. This is the kind of geometry that the Frank Gehry's and the Zaha Hadid's and the brand name architects who are doing the really interesting stuff in the world do. And they'll update that face. And what's a little unique about this facade right now, it may be hard to tell from just looking at it from this perspective. That facade is actually curved. If I really get in there close and see if I can see it for you. There's actually a degree of curvature to it because there's a straight line at the top, there's a straight line at the bottom. that surface actually has a curvature to it. And we couldn't model that using the standard tool, so we have to do that using this model, or this kind of math form modeling. So yeah, we because of the way a lot of organic architecture is working these days, we often get into things like this. Okay, but definitely use it judiciously. Because, you know, there's good in it, but there's also a little more work in it. Okay, so what I would love to do now in our last little bit together is actually talk about this building and how we convert this now into, you know, just continue to edit it as though we're going to add some structure to it, add some stairways to it. You know, we only have a shell right now, but we need to keep on going in terms of making this a building. So a couple things I wanted to show you today. I wanted to show you how you could actually put some shafts in the building, some openings that some stairs would be coming up like a core of the building. And also talk to you a little about how we can go through and put the structure in the building. Right? So to do that, let's go ahead and switch over to the floor plan because it's going to be pretty similar. If you get to this building and we go taking a look, any of the floor plan levels, you'll see there's a real building hanging out there. Okay, it's a little hard to see right there. That's that curving glass surface on the front. Okay, but let me just do it on level 1 for right now. So one thing I might want to do this building is put some cores. Might be an elevator core or a stairway core. And how we do that is pretty much just, we're going to start with the elements that we're used to. I want to cut a hole in all those floors that are going up. I'm going to use the shaft tool. See if I can work with this. I have a twisted building, which will make it a little hard. I'll put a core down on the end of this building, down over here.
Glenn, quick question. The shaft tool in the architecture tab, is it the same? Does it do the same function with the shaft tool in the structural tab?
Yes. As far as I know, it does. If it doesn't, I have to think about what the difference is.
Yeah. Okay.
We'll take a look at it in a second. Okay, so for the shaft over here, let's give it a start at level 1. Its height, let's not make it unconnected. Let's actually make it go all the way up to the top of the building, and we can decide whether it's going to go up to the roof to a mechanical penthouse or not. Okay. Now, we did this morning. People were saying, well, hey, what's happening? Let me see if I can do the section box and show you how it looks like. You can see inside here. Am I that in the building? Let's see what I do with my shaft. My shaft doesn't seem to be here. I want it to be here. I must have set some sort of properties wrong. Let me go to the structure tab and see if we can get a lot of no difference. Nope, same difference.
Yeah, same thing.
Try that again. See if I can pay attention and figure out what I did wrong last time. Oh, base is level 14. That was my problem. Base is level 1. Top is level 14. It's always something. Say okay to that. Go back to 3D. Let's take a look. You can actually sort of see the shaft there. I'm going to pull this section box out a little. Too far. Okay, you can sort of see that shaft there. The other thing that may sort of bother you, though, is that mass is hanging around. So as we look at that mass hanging around, it's sort of just obscuring your view of the shaft. So if we want to go ahead and take care of that, we're just going to hide the mass. Because, once we've generated the form, we don't necessarily need to be looking at it all the time. So we have a choice here, either show the mass form, or this will turn it off, or let it be controlled by the visibility graphics setting. So, show mass. Show mass view by settings. Let me see what my visibility graphics settings are. I just did a VG. Okay, still turned on. I'll turn that off. That looks more like what I have in mind. Okay, so you can put shafts in your building. Okay, generally what will happen is, just so you know, in a building like this, we'll tend to have, 2 or 3 different fire stairs. There's an issue about egress. When you talk about that just from an architectural standpoint, it's all really determined by the notion of being evacuated to safety and the maximum distance you can go from an office or any location to an evacuation path. So whether this building is going to take 2 stairs or 3 stairs, I don't know. We'd have to look at the length and the rules. But I do know it'll take at least 2. Because in a big commercial-like building like this, if it has over a certain number of occupants, we always have to provide at least 2 exit routes, just to allow that if on one end of the building there was a fire or some sort of blockage, there'd be an alternate route. Okay, so that's more of an architectural issue. Let's go to put some stairs in here. Now, this shaft is just a hole. Someone asked this morning, shouldn't it have some walls around it? And it should. Even an elevator shaft, it has some walls that go around the core. So we could add those things in there too, but I'm just going to make it relatively quick. So I'm going to put some stairs in here. 12 and 14, 13 and 13. I'll come back and just do a nice dog leg stair. Maybe I'll just move that whole thing over so that it's kind of up against the side of the shaft. Okay, and then even here, I can go through if I wanted to put some walls in. The other thing I can do with the stair is, just since I have the stair and it's going from level 1 to level 2, I can make it a multi-level stair. I should check to see how many floors I actually have in this building. And kind of create it all the way up there. Looks like I have a little bit too much there. Bring me down to level 5 if I want to go to the last full floor. So again, we're just starting with this very basic thing. We're starting to add architectural elements to it. Oh, in the same sense, my shaft is looking awfully big right now. I might be able to kind of swing that up a little bit smaller. I'll leave some space for the elevator that's going to go in later. Okay, and I can take this stairway, and I can take this shaft, control click it. I can't tell if I actually got the railings too. I don't think I did. Control, control, control. Okay, so I got all 3 of them now. So maybe I'll copy this from this side of the building. Oh, that's interesting. I'm doing a bad job of copying. Actually, let me do that again. I should show you the right way to do it. Shaft. Oops, I'll do the stairs first. Stairs. Left. Copy. I want to grab some handle that I can control. Really, it's the displacement point. If you like to think about that. And now I'll put it over here. Okay, so now I have these two on either side of the building. Okay, not too awfully bad. We're actually getting a lot of building here for not so much work. The other thing we wanted to show you tonight is this notion of putting some structure in this. So we kind of touched on this some in terms of putting together a real simple steel structure one day. So let's see if we can just kind of keep on going with that theme. In terms of putting the framing in, a really good thing is to sort of put some structural grids in and then put some columns and beams that sort of work between those grids. So if I was a structural engineer looking at this, I might go ahead and I'll put some structural grids in here. Looks like I'm not, oh, it's kind of interesting to see. Getting it to line up perfectly is kind of hard. Let me kind of approach it a little bit differently just so I can give you a better technique. Okay, one question you're going to think about is when you put the grids in, are they going to be at the outer surface of the building or are they going to be inset just a little? And actually most people will inset them just a hair. So that the grids and all the columns are inside the surface of the glass. So I'm going to put them in about like 1 foot in by offsetting. And I'm going to pick that wall. And why am I doing this? It's really just that. Although I'm only getting the single. Actually, let me see if I can do it a little different. I cursed myself by putting this building at like not 90 degrees. So it's making my life a lot harder. I should probably reorient the project orientation. That one got the whole wall. That's 1 foot on the inside. 1 foot on the outside. That's just not going to want to do it. Let me try putting it negative 1 foot. Again, I'm sort of fumbling around trying to fight with Revit. I'm not happy. Okay. Let me try drawing it. Eventually, I'm going to give up. Just so you know, there's always the end point of the story is eventually I'm going to give up and rotate the building. Oh, here's what I could actually do. I could just stick to the end point. Maybe that's not so bad. Then go back and choose the grid. There it was, grid 1. Okay. And now that I have it, do a move on it. You'll find I often beat on things for quite a bit, and then I finally figure out some way to do it. Okay, in the same sense here, since I'm having such a hard time drawing that, I'm going to copy it over here. And I can put some sort of dimension in there. And let's say the column grid. What I got there? 60 feet. That's looking a little tough. I might need to put another column grid in here. Let me edit that. So all of them. Come on. Edit. Choose. I'll make them equal. That's a little bit better. Okay. In the same sort of sense, I can do the column grids in the other direction. So maybe I'll do that with a nice array. Because you have a lot of choices. I'll put a grid in here. I'll choose it like that. I'll move it. Okay, this is going to be like grid A. Now, for this other one, if I have a very regular column grid that I want to put in there, maybe I'll even do an actual array. I like arrays. I'll say array it. I don't want to group them, so I want to keep them independent. I'm going to go through and put in like 8 of them. Give it some sort of distance, like 30 feet. And I got a grid in the other direction. That wasn't too bad. Maybe I need a 7th one or a 9th one. Oh, since I went through and didn't array them, they're no longer attached. Interesting. Okay. 28 seconds. Okay. We started with some basic grid lines. Actually, I think I'll be good about this. I'll sort of push that one up since I don't want the columns to run, or the beams to run right to the stairway. Slightly uneven bays on the end. But we're now ready to start playing the columns and let's see if we can do this. Okay, let's see, can you hear me?
Yeah.
Okay. Every like 20 minutes or so, my headset decides to do something weird. But we're okay. Okay, so let's go ahead. We'll put some columns in here. We'll put these nice concrete columns. Looks like they don't have any. So I'm going to load some in. Structural columns. Let's do a nice concrete square column. Okay, once I have these, I can, of course, place them on the grid, one at a time. But that doesn't seem like a very good way to do it. So I'm going to just choose at grid and put them in that way. Actually, before I do this, because I know how I always get myself in trouble, let me make sure I'm putting them in. I'm going to put them in the height method. Go to level 2. So I'll put them in at grid. And then I'll just go through and choose, control click, control click, control click, control click, control click. I got a lot of columns in there. Take a look at that in 3D. They're all hanging around down there on the first floor right now. Not too bad. If the slab was good enough, we might not need any beams, but I think we're probably going to put some beams in this. To put the beams, I'm actually going to go to the ceiling plan of level 1 because I want to put them above my head. So we're hanging around on the ceiling of level 1. I'm going to put some beams in here. Again, all I have is these wide planned columns. So I'll load in some nice concrete ones. Structural framing. Concrete. Nice beam. We have some different sizes we can choose here. I'll make them a little smaller. And am I going to say like on grids just to make life a little easier? I can choose this one. Control clicking. Actually, I should pay attention before I kind of put them all over the place. I want to put them at level 2. I realize that about halfway through. So I'll choose this one. Finish that up. Okay. It's telling me they're not visible. That probably has more to do with the fact that the visibility graphics is set so that it's not showing the columns or the beams. If I go to visibility graphics, you can see if that's true. Structural framing's just turned off right now. Okay, there you see them. Great. So we have, now we have these nice little waffle bays that have these beams that are all wrapping around and touching those columns. So the final thing we might do, just in the spirit of the way we've been doing a lot of things, is I'm going to do some copying. The way I'm going to copy is actually just to drag around and select everything. And I'll filter out things that I don't want to copy. So I just really want to get the structural columns and the structural framing. Everything else in there is just kind of okay to be just without that. We don't want to need to select them. I just want that little piece. And then we'll copy that and paste that up. Again, copy. And I'll paste it to selected levels. Put it up like 2 to 6 or something. Hopefully it'll paste it in there. Let's take a look in 3D. Okay, so we actually have a pretty good looking little system happening around there. We got some structure, we got some stairs, we got some steps. And really, that's how far we're going to push in the next assignment. We're really going to just take our basic shapes, put a skin on them, going to put the structural skeleton inside, go through and put some like basic cores and shafts, and just really say, you know, that's our first cut at what this building's going to look like. We'll continue with the building in future weeks. And we're going to add a lot more to it. We're going to add mechanical systems and ductwork and some plumbing and start adding some interior walls. But at the first level, we're just going to stop here and just say, this is almost the level at which a lot of buildings get built and you just have the shell of a building. And then it's ready for tenants to come in and start specifying the individual things they want to have happen inside that shell. So I'll just pause there for a second because I know I just went through a whole bunch of steps right there in terms of putting those columns and those beams in there and then copying them up. We're going to do that again in more detail, but we just kind of get a sense from you about that workflow and whether that sort of makes sense or the questions you have about the overall approach, not necessarily every individual step, but you know, how did that feel just watching that go through?
Make it look very easy.
So you make it look very easy.
Oh, it always looks easy the first time too, because I've done it a couple times.
Yeah.
Nah, you'll go ahead and practice on some relatively small things. But yeah, if you understand that overall approach, you know, you get pretty far. Yeah, and there's always specific problems we end up solving. So you're going to have some time to sort of play with it. We're going to give you the assignment, so probably over the weekend, and you're going to have till not Tuesday, this coming Tuesday, but the following Tuesday to get it done. So just really kind of starting with this notion of an overall form, choosing a form, and then ultimately just kind of creating the skeleton of the building. So let me give you the two last thoughts, or one last thought. It's really two variations on a thought. Okay, and that is, we've been creating all this stuff and putting our structure in and stuff like that. And I'm hoping you're getting the sense that, well, it's really not too bad in terms of the type of modeling we're doing right now is really back to doing the detailed modeling that we have been doing. So if I want to put in some walls on the inside of the building, I could choose the wall tool, choose a type, just like we have been doing. I can choose a height, like going up to level 2. And I can start putting interior walls in here. And I can start putting doors in there. And it's all the things we're sort of used to doing. Okay, and that's going to work exactly the way it has been working. Okay. The difference I want to sort of let you know about relative to these math forms is very specific to the notion of the types of walls and how we have to address them. Okay, this wall over here on the end of the building, you might remember that's a perfectly vertical wall. Okay, and the nice thing about perfectly vertical walls is they operate just like the standard walls we place. So a nice perfectly vertical wall will do this. If I stretch, well, that's interesting. That wall is not perfectly vertical. I was sort of worried I might have torqued it. I could sort of tell based on right over here when I was pushing and pulling around, it actually is sloping a little. Let me do this on the other side. Over here, this wall, I believe, is perfectly vertical. About to be proven wrong, no doubt, but we'll try it. We'll create this wall. Okay. And when we come through and we bring it up to the wall there, it's funny, I actually torqued the whole building. That is so sad. Yeah. Let me fix it, and I'll do something else that's really quick. Hang on. Zoom to fit. Show the masses. Let's go to a building I haven't torqued recently. Okay, put some walls on here. Okay, put a wall over there. I'll just torque that one surface right here. Put the curtain wall on that one. Okay, with any luck, this should be a little bit better. I'm going to be over here, and in this view, the wall on the right is a flat one, this is a sloping one over there. So if I put a wall in there, everything's happy. When it comes time to actually join the wall to the vertical wall, it'll do what we want it to. It did a nice join there. It joined right in, it cleaned up, it made a perfect intersection. Okay, and we like that. So even if you generate a wall with a map, if it's a vertical wall, all the rules apply to you. What I want to differentiate that from, you'll probably figure out by now, is if I take a wall and I bring it up against a sloping wall. A non-vertical wall. It could be a curve, it could be sloped, whatever it is. But it doesn't hug in there. It doesn't actually join the way we want it to. It's there, but it's kind of loosely there. It's just kind of there in the same location. It's not actually intersecting, or it's not joining. Let me see if I can show that to you in 3D. So the problem is, when you take an interior wall and you join it with a sloping wall, we got a little extra work on our hands. Now, that's a little more work for us as modelers The truth is, it's actually a lot more work for us as construction people. So when you think about trying to join walls to sloping surfaces, there's challenges. Often we won't go through and do this, or if we do, you end up paying an awful lot for it. It's certainly not an easy thing to do. But how we handle this from a modeling standpoint, just so you know, is if we want to go ahead and take that wall and have it follow that sloping surface, we can say edit the profile. And what's that all about? That's what we did very early on, where we could take the wall and just alter the shape of it. We sometimes do this under stairs. We've used it to change the tops of walls. Here I'm going to use it to actually lock the side of the wall to the sloping wall surface. And I'll trim that up. Okay, so what is that all about? That's just kind of just trimming off the end of the wall. In a way, that's just exactly what you want Revit to do for you automatically. It just wasn't smart enough to do it. So we had to tell it how to do it by giving it a little bit of help. So in terms of these mass-generated surfaces versus kind of standard surfaces, the important thing I want you to carry away is if a mass-generated surface creates a horizontal or a vertical surface, and it's perfect, all the rules will apply that you're used to having applied. But if it has a curvature or a slope to it, it's a little bit different, then we might have to do a little manual work to go ahead and clean it up at the end. Okay, so that's the only distinction there.
Yeah.
Okay. Any questions about that? You feeling good? More or less? You'll know better after you try it.
Yeah.
Okay, no worries. Yeah, we saw it here. We're going to keep on doing this a couple times with some more nuance and stuff. So hopefully we just planted some seeds about where we're going to go for the next couple sessions. Okay, why don't we do this? Let's adjourn for the night. I want to thank you guys for sticking through and putting up with the sound and the funny remote presence and all that kind of stuff. And hopefully we got some good stuff conveyed for you that'll give you an advantage on the next assignment. But why don't you get yourself out of there and go enjoy what's left of the game.